So now we are coming to the chapter 3. Chapter 3 covers analysis. Means if you got bigger circuits, Ohm's law and nodal node currents and loop equations will not satisfy. So we need some methods. That's called analysis. So we have two basic methods. That's called node analysis and mesh analysis. So we'll study in this node analysis. And we'll study node analysis with voltage sources. So it's also called supernode. Why? The node analysis always contains current sources only, generally, node analysis. So if we have a voltage source, then how to analyze the circuit by using node analysis is called supernode. So I will delete this topic, which is not useful for your computer engineering in future also. So we will study node analysis. Means item number 3 is deleted. Okay, in notes it is there, but it will not be asked in the future. Now next, another is called second method, mesh analysis. Like a node analysis, we have another method, mesh analysis. Like here also, if we have current source, not like voltage source, then it is called supermesh. Supermesh, that is called when we have current source. Generally, mesh analysis is a voltage source analysis. It has voltage sources, not the current sources. So if we have current sources, then it is called supermesh. If a node analysis have a voltage source, it is called a supernode. So generally node analysis, which source current sources we have? Current sources. Mesh analysis, which source voltage, which sources we have? Voltage source we have. Now here also mesh analysis, that is super mesh, I'll delete. So only two topics we are studying here now, node analysis and mesh analysis. So today we'll finish node analysis and next class we'll finish mesh analysis. Next week we'll go for the chapter 4. So that in mid we have chapter 1 to chapter 4. Now coming to okay, now that we understand the basic circuit theory, including Ohm's law and Kirchhoff's laws like current law and voltage law, we can use them to learn two important circuit analysis method, that is called nodal analysis, which is systematically applies Kirchhoff's current law, because at a node means current means Kirchhoff's current law. Next, second one, mesh analysis, which systematically applies Kirchhoff's voltage law. Right, this is mesh. Mesh means called loop. What is a mesh? It's a closed circuit mesh. So loop, when loop is there, which law is coming? Kirchhoff's voltage law. So with the two techniques introduced in this chapter, we can analyze any linear circuit by forming a set of simultaneous equations and solving them to find the required current and voltage values. To find the required current and voltage values, we can find. How to analyze? We have 2 or 3 methods. In that, only 2 I will discuss. That's called elimination technique method and Kramer's determinant method, means matrix method. So we'll study that one. So total 4 topics we can say. 2 means one is node analysis, one is mesh analysis. In node analysis, 2 techniques, that is elimination technique and matrix method technique, Kramer's method. And same thing, mesh analysis also 2 techniques. So total 4 items we are studying in the chapter 3. So what is node analysis? Node analysis provides a general procedure for analyzing circuits using node voltages. Generally at node, what will be there? Current entering, sum of current entering equal to sum of current leaving. So this is one equation. In this equation, remove the current and put voltage equation. I equal to, what is the equation? Ohm's law, V by R. So first node currents at particular node, one equation will come. Rearrange that equation with Ohm's law with the voltage. So it's called voltage, node voltages. That's why we call it a node voltages. Now, if you find that node voltages as a variables, once you know the node voltages as a variables and you will solve the equations and you get the voltages, then resubstitute into the current equation. Then you will get the currents also. To simplify matters, we shall assume in this section that currents do not contain voltage sources. Means current sources is there only there in the node analysis, no voltage sources. In the later section, that is in supernode, we will substitute the voltage also. Okay, in node analysis, we are interested in finding the node voltages only. Given a circuit with n nodes, generally any circuit, how many nodes will be there? N nodes. Okay, in that one node will act as a reference node or zero node or zero voltage node. will act as. By default, in the question itself, we will give which is the reference node or which is the ground node. That zero node also called as ground node, reference node, or zero voltage node, where there is nothing will be there. The voltage value is zero. So no need to write any equation, Kirchhoff's current law equation for that node. So how many nodes remaining now? Maybe n nodes are there. One node will always reference node or zero node or ground node. So one node will be there. So remaining nodes will be n minus 1. So that n minus 1 nodes, we need nodal voltages or Kirchhoff's current law equations for those n minus 1 nodes. So we are solving only n minus 1, not n nodes. What are the we follow 3 steps. First one, select the node as a reference node. You can select, or in the question it can be given. In the question, the ground node will be given, or you can select any node as a reference node, up to you. Later, if it is not a reference node, it will give us some value. So generally, in the question itself, we will assign this is a reference node, we will tell. This is a ground, we will tell. So now assign voltages V1 to Vn minus 1, because one node is already reference node. So how many nodes remain? N minus 1. So each node will be voltage V1, V2, V3 up to Vn minus 1. For n minus 1 nodes, we will assign it. First node, second node, like that up to n minus 1. Now so apply second one. Apply KCL, Kirchhoff's current law, at each node. That up to n minus 1 node, that is called non-reference node. If the one is reference node, remaining all nodes also named as non-reference node. Okay, so that n minus 1 non-reference nodes, we have to write Kirchhoff's current law equation, I plus I1 plus I2 plus I3 equal to I4 plus I5 plus, like this one equation. Now arrange that equation with Ohm's law, which is I equal to voltage divided by resistance for that particular branch, to simplify. Okay, now last one, solve the resulting simultaneous equations to obtain the unknown node voltages. Only 3 steps. 4 steps generally, because here we are rearranging Kirchhoff's current law with Ohm's law. So another step we can say. So in 4 steps we will complete it. Now come, the reference node is commonly called as a ground, since it is assumed to have a zero potential. Voltage value is 0 at that reference node. Let's have one circuit here. What you are observing in this circuit? How many branches? Anyone? Come branches. Branch, elements, branch elements. How many? Okay, branches equation you can apply. What is branches? B equal to number of nodes plus number of loops minus 1. So nodes how many? 1, 2, this is 3 nodes. Plus how many loops? This is 1 loop. This is the second loop. This is the third loop. So 3 plus 3, how much? 6. Minus 1, how much? 5. How many branches? 5. How is selling 6? 1 current source is 1 branch. This current source, another branch. R1, R2, R3. 3 branches. I am telling branch. Ground is a node. Ground is a zero potential node. There is no, see, ground is zero potential node. There is, it's not an element. Elements are resistance, capacitance, inductance, voltage source, current source. These are the elements, right? Or branches, we can say. Elements, branches are same. Okay. Ground is just like a zero. One node. Ground is one node, which is a zero connected to the earth. Nothing is there. Okay, good point you asked. Okay, so ground is now, it is already given, which is the reference node. This is a reference node, it's named as 0. Now, node 1, node 2 already we marked. Okay, now what is the next step? We have to find the Kirchhoff's current law. For that, what we note, we need a current numbers, I1, I2, I3, right? So first, I1, this is the current already there. This is I2, already there. So no need of any current numbers. Later, we will put some numbers for the problems. Now here only for explanation. So for this R1, what will be the current? It will be from this node 1 to ground. That means current is going down, we can say. Means higher potential to lower potential current will flow. Will agree or not? What is the current? Always flow from higher potential to lower potential. Where is the lower potential here? 0. So it will flow from 1 to 0. Node 1 to 0. So current direction is downwards. Same R3 from node 2, the current direction is downwards, means leaving the node. Now the problem here, node 1 and node 2 for the R2, what is the current I2? Current I2 will be from this node. You can assume current direction from 1 to 2 is from left to right, or you can assume current direction from right to left also, up to you. When the natija will come, when the result is coming, minus sign will come. That is saying that what you assumed is wrong, but no problem. The steps are correct. What you followed, steps are correct. If minus coming in the result I2, then you have to change the direction. What you assume direction is wrong. Okay. So you can assume anything here. I will assume generally left to right. So what is the current direction? 1 to 2 means current is from SR to ME. Check here. Okay. See, I assume SR to MN I2. Remaining okay as it is. That is V2 to 0. That is top to down. Here also up to down. V1 to 0. Now, step 2, what we are telling? Kirchhoff's current law. We have to apply at each node. So, what is the first node? This one. First node. What is the current centering in the first node? How many branches first? 1, 2, 3, 4 branches are there. So, how many currents? 4 currents. So, how many currents entering? Summation equal to how many currents? Leaving summation means sum jama. So, what are the jama for entering? Means jua. This node, how many currents entering? V1. This node. This I1 is entering, jua, right. And I2, no, leaving. I1 is leaving. I2 also leaving, right? Only one current is entering. So, I put I1 here. Capital I1. Now, what are the leaving? Capital I2, small I2 and small I1. So, I2 plus I1 plus I2. These are the leaving. First. Next, second node. What are the currents coming? Entering, small I2. Capital I2 is also entering. Only leaving is I3. Right? Correct or wrong? Check here. How many currents are entering? Jua, I2 and small I2. And leaving I3. So I will write small I2 plus I2 equal to V3. Now, what is our step 2 in part 2? Part 1 is finished. That is Kirchhoff's current law. In step 2, part 2 is apply Ohm's law for each current. So, each current. This current already known. There is no Ohm's law here. Direct current is there. Because only current is there. We can't write Ohm's law there. So, for resistance, we can use Ohm's law. V is equal to IR. Right? So, for small I1, I2 and I3, we apply Ohm's law. Now, there is a term. Current flows from a higher potential to a lower potential always. Like V1 to 0, higher potential to lower potential. V2 to 0, ground, lower potential. So, we use equation I equal to V higher potential minus V lower potential divided by R, Ohm's law. V higher minus V lower potential divided by R. Lower potential for this V1 to this ground. What is lower potential? 0. So, V1 minus 0 it is. For this R3, what is higher potential? V2. What is the lower potential? 0. V2 minus 0. So, V2 only it is. No problem. So, like this we have to arrange. Now, for this R2, what is higher potential? Because current is from left to right. We assume left to right. So, when current is moving from the resistor left to right, which is the higher potential? V1 will be higher potential and V2 will be lower potential. So, V1 minus V2 will come. If the current direction is in the opposite direction, reverse I assume, let us take, then V2 minus V1 we have to write. Work done. How the work done of the current? Work done will be from starting point to the ending point. Current is starting point is V1, ending point is V2. So, starting point more work done. At the end it becomes 0. There is a work done. So, V1 minus V2 here because of this current direction. If the current direction is reverse, it is V2 minus V1. Okay, now come to first one. What is I1? V1 minus 0 divided by R1. And we can write in terms of conductance 1 by R1 G. So, G1 V1. So, what is I1? V1 minus 0 divided by R1. Next, I2. This is the I2. So, this is I2. V1 minus V2 divided by R2. V1 minus V2, Taksim R2 divided by R. We can write 1 by R2 is G2, V1 minus V2. In conductance also we can use, no problem. I3. Where is I3? This one. V2 minus 0 divided by R3. V2 minus 0 divided by R3 or V2 by R3. And 1 by R3 is nothing but G3. So G3 conductance. So you can use like this also. Same thing. Now substitute these equations, Ohm's law values in the two upper equations. First node Kirchhoff's current equation, second node Kirchhoff's current equation. So first node Kirchhoff's current equation, what we wrote in the previous slide, I1 is equal to I1 plus I2 plus capital I2, right? So right, I1 is equal to capital I2, I1 plus I2. What is I1? We have here V1 by R1, V1 by R1. What is I2? V1 minus V2 by R2. So we have to rearrange this equation and write in terms of V1 minus V1 and V2, which is equal to a constant. Now next, for second node, what is the second node? Second node, currents entering are I2 and small I2. Currents leaving is I3. So I2 plus small I2. What is small I2 here? V1 minus V2 by R2, small I2, which is equal to I3. What is I3? V2 by R3, V2 by R3. Now rearrange this equation in terms of V1, V2 or V3. V3 not there, V1, V2 only. Then you can solve two methods. That's called elimination techniques and Cramer's. Or you can use in terms of conductance also. These R1, R2 you can use in terms of conductance. So same equations in terms of conductance. Now how to solve? How to solve this equation? Okay. Yeah. Node voltage using the standard method such as substitution method, elimination method, that is called, or Cramer's rule method or matrix inversion method. We have two methods here: elimination method or standard method, or Cramer's rule or matrix method, matrix inversion method. We will study both. Okay, this is called matrix method. How we are arranging? We are arranging. See, we just rearrange this in terms of V1 and V2 for this equation. V1 and V2, if you rearrange in terms of conductance, then it will become G1 plus G2 times V1 minus G2 times V2, which is equal to I1 minus I2. Next, another equation is minus G2 times V1 plus G2 plus G3 times V2 is equal to I2. Like this, we have to arrange. We'll see in the example, we will understand easily. So, any doubts in this? We are going for the problem now. This is only for the steps what we are involving. Okay, one example is here. Calculate the node voltages and node each branch current. Node voltages you can stop, or currents also you can find. So here, just wait. Okay, this is a circuit. How many branches? Anyone? 5. As same like previous, like 5 branches. Then where is the reference node? This is the reference node. This is the reference node, or this? Which is the reference node? Zero voltage node. Which one? Ground. This one is a reference node. I will name it as 0 there. Okay, 0 node. Now remaining two nodes are 1 and 2. Okay. Now currents. Currents, I will put currents, all branches I will put some current number, current names. Okay. I will put 5 amperes as a 1, let's say. So I1 will be 5 amperes in this direction, entering the node. Okay. Then check here. I1 I will entering the node. Then I2 will be in 4 amperes from V1 to V2. Now I3 will be from V1 to 0, I3 down, because higher potential to lower potential. Then I4 is from ground to V2. Okay, I4 is this one entering the node. Then I5 from V2 to ground. Understand how to? Just you can put your own direction of the currents. Only you have to check what is this direction. Remaining in resistance, you put your own directions, no problem. Okay. Now, Ohm's law, first step, Kirchhoff's current law at node 1 and node 2. Node 1, what are the currents entering? Anyone? Come, branches, 1, 2, 3 branches. What are the currents? I1, I2 and I3. How many entering? Juba? 1, that is I1, right? How many leaving? I2 and I3. So, I1 is equal to I2 plus I3 I can write. Now, what is I1? रकम मौजूद 5 is equal to I2 plus I3, right? See here, I1 is equal to I2 plus I3. So what is I1? Already we know. I2 is already given 5 amperes. So 5 amperes, which is equal to I2 plus I3. Now what is I2? This is I2, nothing but V1 minus V2 Taksim R, V by R. Okay, so V1 minus V2 by R. Plus what is I3? When are the I3? This is I3. What is the voltage? V1 minus 0. So V1 minus 0 by 2. So one equation. Now rearrange. I always tell rearrange in terms of V1 and V2 on one side, remaining constant value, any value on the right side. See, we can rearrange this by solving. Take the LCM 4, then it will go here 20, and you rearrange this one. It will become V1 minus V2 plus 2V1. Now you can write the equation in terms of 2V1 plus V1, 3V1 minus V2 equal to 20. In this format only you have to write, which is useful for two method of analysis. One is elimination technique also you can do if you write in this format, V1 on variables on the left side and non-variables on the right side. And in the matrix method also it is easy for you because we have to form matrix. Now first node finished. Now second node, what are the currents? How many branches connected to the second node? 1, 2, 3 and 4 branches are connected. So 4 currents will be there. How many currents are entering the node? I4, I2. Good. I4, I2 are entering. Next, I1 and I5 are leaving. So write the equation. I4 plus I2 is equal to I1 plus I5. I2 plus I4 is equal to I1 plus I5. But what is I1? Khamsa. What is I4? Ashra. So I can write I4 as a Ashra, then I5 as a Khamsa, I1 as a Khamsa. Now what is I2? Where is I2? Yeah, I2 is nothing but V1 minus V2 divided by 4. V1 minus V2 divided by 4. This I2. I4 is Ashra. Now I1 is Khamsa. What is I5? This one. V2 minus 0 divided by Sitta. V2 minus 0 divided by 6. So now rearrange this one. You will get some equation. Then you will rearrange that one. You will get in terms of V1 and V2 as a minus 3V1 plus 5V2 equal to 60. So how many equation we got? Here one equation, another equation. Now by elimination technique. What is elimination technique? Just put V1, 3V1 is equal to 20 plus V2. Now V1 is equal to 20 plus V2 Taksim Kalata. Substitute this in here in the 3V1. Then you will get the V2 value. Once you get V2 value, again substitute back in this equation. You get V1 value. That's called elimination technique. See here. Elimination technique. Then we will get the V2 is 20. Then V1 is we will get 13.33 volts by using elimination technique. But I prefer good methodology. You are engineers, use matrix, because all tools in your future, MATLAB, bigger tools, always follow matrix methods, right? So understand matrix, it will be easy for your what we call another calculus or engineering mathematics. 2 courses are there for you. There also we use this technique, matrix method. It will be easy for you. Calculus and everywhere, matrix method. Eigenvectors, vectors also matrix needed, that also there. So practice matrix method, not the elimination technique. Elimination technique everyone knows. Any other students, non-engineering student also can solve, right? So better go for the matrix method. I prefer that one. I will explain how to do that one. Easy method that is. Now in the previous, the equation, what are the items? V1 and V2. Just check here. Sorry, I have to write here. I forgot. Okay, what is the first equation? 3V1 minus V2 equal to 20. Remember this one. What are the items? 3 minus 1 and 20 horizontally. Okay. Second equation. Minus 3 V1 plus 5 V2 equal to 60. What are the items? Minus 3, 5 and 60. Now check here. You have to arrange the matrix, these two equations in this format. 3 minus 1, 20. Minus 3, 5, 60. Now multiply this, you will get same equation. 3 V1 minus V2 equal to 20. Same. Minus 3 V1 plus 5 V2 equal to 60. Same equation. Okay. So in matrix format, we have to put like this. All the coefficient we have to write. Then put V1, V2 in the column vector. Then on the right side column vector, the other side of the non-variable term. Okay. Now once you get this one, we have just 3 steps. What are this? First take the determinant of this. Then V1 is nothing but remove the first column to keep 20 and 60 here. Find the determinant divided by the actual determinant. Same. Remove the minus 1 and 5. Keep the 20 and 60 here. Take the determinant divided by actual determinant. It will be V1 and V2. No need of any elimination here. Check here. First find the determinant. What is the determinant equation? Diagonally multiply minus. Diagonal. What is diagonal? 3 and 5 is one diagonal. Other diagonal minus 1, minus 3. Diagonal cross. Okay. So 3 multiplied by 5. How much? 15. Minus 1 multiplied by minus 3 plus 3. That is here. You will get 12. Here everyone understand or not? Please tell me. What I want to do? Determinant. What is it? How do you find the determinant? Diagonally you have to multiply. Put minus in between. First diagonal 3 into 5, 15 minus last name. Then this diagonal 3 into 1, 3. Minus minus it will plus. Minus is main important. Okay, diagonal. It will continue. You have to first step itself we don't know, then complete problem is gone. So determinant 1. Now next step is for V1. Finding the V1, we need to eliminate this first column, keep this column here and find the determinant. So V1 is nothing but determinant 1 divided by actual determinant, main determinant, total determinant you can say. So determinant 1 is nothing but remove the 3 and minus 3 with 20 and 60. 20 and 60. Keep as it is this column, minus 1, 5. Now find determinant for this. What is determinant? Diagonal. 20 into 5, how much? 100. Minus 60 into 1, minus 60. So minus of minus plus. So 100 plus 60 divided by what is actual determinant we found here? 12. So 160 divided by 12, 13.33 volts. See here how much we got V1 in elimination technique. Same. Okay. Now V2. V2 we have to remove the second column, minus 1, 5. Then we have to put 20 and 60 here. So 20 and 60 here, keep it here. So 3 minus 3, 20 and 60 your matrix. Now find the determinant of this. Diagonal 3 into 60, 180 minus 20 into 30, 20 into 3, it is 60 minus of minus plus. So it is 180 plus 60, that is 240 divided by 12, 20 volts. Right? Okay. So here, what is V1? There is a V2. V2 is 20 volts here. Here also V2 we are getting. So like this, we have to find the node voltages. Next, currents automatic. Substitute in the Ohm's law, we will get the currents. Like I equal to 5 amperes. I2 is nothing but V1 minus V2 by 4. So substitute what is V1, what is V2, we will get minus 1.6. I3, V1 by V2. V1 by 2, that's 6.66. Now observe here. I2. What is the current? What is I1? Plus 5. What is I3? Plus 6.66. Find I2. Why it is minus? Anyone? Because it's wrong direction. Yes. What we assume is wrong direction. No, it's not a fault. It's not a fault. Perfectly you went the steps. No problem. The result tells that the direction what you assume was minus. Means reverse. No need to do anything here. You can understand that's it. Okay, if it minus is coming, you can understand that, oh, I put wrong direction. It's okay. Okay, it should be in the reverse one. If you, in official itself, you put the reverse direction, it come here positive. Value will same. Value 1.66 only, it will not change. But direction will tell the sign, plus or minus. So this is the one we have. See, the fact that I2 is negative shows that the current flows in the direction opposite to what we assumed. Okay, another example, then we'll finish. Yeah, very soon. Okay, this is the circuit. We want Ix, this is a dependent current source is here. This is a different circuit. Ix is depending on this current source to Ix here. So now put the reference node, this is 1. And this is first node, second node and third node. Okay, 3 nodes now. Previously it was only 2. Now it is 3 nodes here. So currents, put the currents. This current is there. This current is there. Here current, here current, here total currents we can put. So this current 3 amps. And I put I1 in the 4 ohms. I put I1 in the direction I assumed like this. Leaving from node 1, entering in the node 3. Now I2, in the 8 ohms. Because I cannot take some number here because already Ix is given. So I can take Ix as it is, no problem. Now what is I2? From V2, leaving from V2 and entering in the V3, node 3. Now I3, leaving from node 2 and to the ground. Okay, these are the 4 currents. Now, what we have to do now? We have to apply nodal equation for this node V1, V2, V3. First node equation, current's law, Kirchhoff's current law, number of currents leaving summation equal to number of current entering summation. So what is the currents entering in the node? What are the currents entering? 3 amperes equal to, because only one is entering, remaining is leaving. So 3 amperes equal to I1 plus Ix. Okay, this is the first equation. Now what is I1? What is I1 in Ohm's law? V1 minus V3 divided by 4. What is Ix as per Ohm's law? V1 minus V2 divided by 2. Just rearrange in terms of V1, V2, you will get first equation. Second one, at node 2, what are the equation? Currents entering, Ix is entering, leaving I2 and I3. So Ix is equal to I2 plus I3. So what is Ix? V1 minus V2 divided by 2, Taksim 2. And what is I2? V2 minus V3 divided by 8 plus. And I3, V2 divided by V2 minus 0 divided by 4. Same, coming to the rearrange it, you will get in terms of V2, V1, V2, V3 here. No problem. Now, third node, what are the currents entering? I2 and I1. What are the currents leaving? 2Ix. So, I2 plus I1 equal to 2Ix. Now, what is I2? V2 minus V3 divided by 8. Next, what is I1? V1 minus V3 divided by 4. Now, what is 2Ix? Ix we know. What is Ix? Here. Ix is here. So, V1 minus V2 divided by 2. Okay. Ix is nothing but is here. Ix is here. What is given in the question. So, V1 minus V2 divided by 2. Now, rearrange this. It will come in terms of V1, V2, V3. Now, we'll write here. See. Same thing. It is coming in this equation. 3V1 minus 2V2 minus V3 equal to 12. One equation. Then, at node 2, Ix equal to I2 plus I3. Now rearrange everything. Minus 4V1 plus 7V2 minus V3 equal to 0. At node 3, I1 plus I2 is equal to 2Ix. Now substitute what is 2Ix? 2V1 minus V2 divided by 2 will cancel. And we substitute, rearrange this. 2V1 minus 3V2 plus V3 is equal to 0. So this is one equation. This is another equation. This is third equation. All are containing V1, V2, V3. Variables on the left side, non-variables on the right side. So, by elimination technique, you will get V1 and V2, V3, 4.8, 2.4 and minus 2.4. Elimination technique, you can get it. But I prefer matrix method. Okay. Okay, now mesh analysis. So, as per previous class, we finished node analysis. Okay, node analysis with the current source. Now, mesh analysis is basically with a voltage source. So, mesh analysis provides general procedure for analyzing circuits using mesh currents as the circuit variables. So, in previous topic, node voltages for node analysis. Here, mesh analysis, mesh currents we need. So, we need a loop current generally. Mesh means loop currents. A mesh is a loop that does not contain any other loops within it. Means a mesh is a loop which does not contain, means it doesn't have any other loops. Only one loop means only one loop, no other branches, nothing. So only one loop it should cover. How it is covered, we will check. Using mesh currents instead of element currents as circuit variable is convenient and reduces the number of equations that must be solved simultaneously. Using mesh currents instead of element currents as circuit variables, convenient and reduces the number of equations that must solve simultaneously. Means continuous one mesh current is easy to solve the solution. Okay, mesh analysis applies KVL to find unknown currents. What is KVL? Kirchhoff's voltage law. Kirchhoff's voltage law we can use for finding the mesh analysis. Mesh analysis applies KVL, Kirchhoff's voltage law. Now see here one example circuit here. Figure having how many branches? 1, 2, 3, 4, 5 branches. right? Voltage source, 2 voltage source and 3 resistances. Total 5 branches. Here no need of any reference node here, reference 0 voltage or ground, no need here. This general circuit, if any general circuit is given, we can start doing. No need of thinking about where is the ground, no need. Just what we have to do, see the closed paths. How many closed paths are there? You can see here 1, resistance 1, resistance 3 and voltage source V1 will make a one closed path. Then resistance R3, R2 and V2 voltage source will make another closed path. So we have 2 loops in this. Another rule. You can, before starting how many loops are there, you can note down what are the nodes first. A, B, C, D, E, F. These are the path nodes. Okay. Now we can start from the first node A, go to the B, then go to the E, F, then come back to the A. This is the loop rule. What is the loop rule? Start with the one particular node, go with the other nodes and come back to the same node and it become one loop. Same second loop, B, C, D and E will become another loop. Now 2 loops are there, but one confusion will there. Datur, we can ask A, B, C, D, E, F also one loop? No, because current cannot jump from this resistance R3. When loop is going, must be a one inner closure loop. Outer closure loop we are not considering, because in this closure loop ABC there is a junction R3 where current will divide there. So we cannot consider that one. That we have to take care. So the paths are A, B, E, F, A and B, C, E, B. Paths are B, C, D, E. Right. B, C, D, E, B again. So these 2 are the paths already mentioned here. What are the A, B, E, F, A, B, C, D, E, B? 2 are the mesh paths here. These mesh paths. Now coming to the another one what I mentioned. But the path A, B, C, D, E, F, A is not a mesh. Mesh means a closed loop. The current through the a mesh is known as a mesh current, loop current, mesh current, same. Okay, mesh current. We now new name mesh current will call. In mesh analysis, we are interested in applying Kirchhoff's voltage law. In node analysis, we are interested in applying Kirchhoff's current law. But in mesh analysis, always apply Kirchhoff's voltage law to find the currents in the given circuit. Now, in the mesh analysis of a various circuit with n meshes, we take the following 3 steps. So, like the 3 steps in the node analysis, here also we have 3 steps. What is the first step? Assign mesh currents I1, I2, or IN to the meshes. See, loop currents, mesh currents is like this. The saham is here, rotation saham. The arrow will come. That is your mesh currents. 1, 2, 3, up to n meshes, n currents. Now, apply KVL to each of them n meshes using Ohm's law to express the voltages in terms of the mesh currents. Now you write I1, right? You have to use the Ohm's law. Ohm's law here, voltage V1 as it is. Now here Ohm's law, what is here? I1 R1. This is the Ohm's law. Now convert it into voltage also, no problem. Next here also R3, I1 R3 is another voltage. So like this we have all the voltages here. Ohm's law, we have to use Ohm's law to write the voltages. Now solve the resulting n simultaneous equation to get the mesh current. So once you get the n number of mesh equations, you can solve n number of mesh equations to get the n number of currents first. First voltages, then currents. We can check it. Voltages means we are getting voltages in the mesh equation with the current form. Ohm's law, V is equal to IR. So that I and R is in the format current and resistance. So the mesh equation will be in the form of current and resistance. Node analysis, the equation in the form of voltage divided by resistance was there. Here the mesh equation is current multiplied by R. Let's see one example. This example is having same, no, we are continuing how to solve. So once you get the mesh equations, you have to solve the mesh equation to get the currents. So the first step requires that mesh currents I1, I2 are assigned to mesh 1 and 2. So this is I1, which is capital I1 is current in the resistance. Capital I2 is a current in the resistance R2. Capital I3 current in the resistance R3. This is different current. Mesh current is small I1, small I2. Mesh current is different. Branch current is different. So that's why the huruf, the letter is capital and small. So be careful when you're writing. Don't confuse with the letters. Small letters for the mesh current and capital letter for the branch current. Okay, it is quite opposite to the node analysis. Node analysis, small huruf, that is small letter, is for branch current, and capital letter is the source current. Source current, capital letter I1, I2, capital I1, capital I2, capital I3 is for source current, and small I1, small I2, small I3 for branch current, element current. But in mesh, completely opposite. Small I1, I2 are the mesh currents. Capital I1, I2, I3 are the branch current. So now it is conventional to assume that each mesh current flows clockwise. You can assume anti-clockwise also. It's up to you. Like in the node analysis, the current direction in each branch you can assume, right? I told you when the result comes, if it is coming minus, it tells that what you assumed is reverse. So here also the mesh current direction, the loop current direction, you can assume clockwise in general. Anti-clockwise also no problem, but follow one method. So clockwise always follow it. The second step, we apply KVL to each mesh. KVL to each mesh. So first mesh, what is the KVL? Kirchhoff's voltage law. So start from this point, from this voltage, that is V1 voltage, KVL voltage law. So current leaving from the source, so V1. So current entering the resistance, it is I1 R1, right? Now here small change is there. See here, current is leaving always minus, same, right? Current leaving is minus V1, plus current is entering resistance R1 small I1. This I am considering I1 R1. Then R3. In this R3, what are the current? I1, but it is not sufficient because I2 is also moving in the R3. Both currents in R3 is depending. Okay, R3 is depending on both the currents, first loop and second loop. How the current in R3 is downward. How the current in the R3 based upon the second loop? Upward. Okay, so downward is nothing but positive and this upward is negative, opposite. So I1 minus I2. So R3 times I1 minus I2, which is equal to 0. First loop equation. Now, as per, like a nodal analysis, always arrange equation in terms of first term, second term variable equal to constants. Here also, what are the variables? In this, what are the variables? I1, I2. Right? I1, I2. Small I1, I2 are the variables. What are the constants? R voltage source. Voltage source. V is a constant. To take it other side. Solve the equation such that I1 plus I2 or I1 minus I2 equal to something like that. So we'll see in the example problem. So we can write like this. See, I1 R1 plus R3 times I1 we can write minus R3 I2 equal to V1. V1 having the some value in the question it will given. So R1 R3 is given in the question. V1 is given in the question. So unknown are I1 and I2 only. Okay, so we have to form the equation in such a form that I1, I2 will be on the left hand side, that is variables, on the right hand side constant. Now second loop, coming to the second loop, I will start with R3, no problem. So R3, when I taking the direction, what it will be? I2 as a reference. So leaving the I3 entering. So I2 minus I1 or I1 minus I2? I1 minus I2 time. Yes. I2 minus I1. Why? See, which is the reference the direction of the current? Our reference is the direction of the current. I2 is we assumed in which direction. So this how is entering or leaving we have to decide. In this V2, current is entering to the plus. When current is entering the plus, it is a V2 plus V. See, plus V. Here, minus V1. How? this I1 is leaving the plus, so minus. Here current is entering the plus, so it is plus V2. So like this, move with this current only, move with this current, go to the R3, this direction is our reference, then R3 is there nothing but what? I2 is our reference, so I2 minus I1, our reference is I2, so I2 is entering the resistance, so I2 minus I1 times R3, I2 minus I1 times R3, check with our direction, what is our direction? I2 is our direction, so starting point of the resistance is down only, so when starting point is, this is a higher potential, this is lower potential, so as per that I2 is the having maximum value, so in opposition I1, so I2 minus I1 R3, same R2 plus R2 I2, because our direction only is there. So this is your equation. Here you will get some confusion in the second loop. First loop okay as it is, normal KVL you can apply, but in second loop our reference direction we have to take. Our reference direction is I2, not the direction of this capital I2 small I2, no. Our what is the direction of our loop direction, mesh direction, what it is. So same rule, direction of I2 is entering the plus of the source, so it is plus V2. If it is leaving, it is minus, plus V2 it is entering, so plus V2. Now R3, I2 is the main reference, so I2 minus I1, the other one. Then here also in R2, I2 is entering the R2, so plus R2 I2. So like this you have to write the equation and rearrange. When you rearrange the equation in terms of variables and constant, R3 I1 minus R3 I1 plus R2 R3 times I2 equal to minus V2. So this equation and this equation form the two major simultaneous equations. We have now two techniques. One is elimination technique and Cramer's rule technique. Cramer's rules I prefer. Okay. The third step is to solve the mesh currents, putting the equation 3.13 and 3.12 in matrix form, Cramer's rule method. So what is the first one? R1 plus R3 minus R3. R1 plus R3 minus R3. R3 minus R3, R1 to R2 plus R3 minus R3, R2 plus R3, and I1 and I2. So I1 and I2 as it is. Other side V1 is there, minus V2 is there. Other side V1 is there, minus V2 is there. So now take down the determinant. Then take down the determinant 1 by V1 and V2, replacing these two elements, determinant 1. And replace the R3 and R2 plus R3 with V1 and minus V2, take down another, take out another determinant delta 2, which will give the two determinant values, and basic determinant value we already found. So delta 1 by delta is V1, right? Yeah, delta I1, sorry, I1 is delta 1 by delta. Next I2 is delta 2 by delta. So which we can solve after the mesh currents. Notice that the branch currents are different from the mesh currents unless the mesh is isolated. So we are not isolating any mesh. So branch currents and mesh currents are different. That's why small letter and capital letter major role plays. Okay, we use I, small I for mesh currents and capital I for the branch currents. Where I1 and I1 with capital I1, which branch current, capital I1 is also equal to small I1 in the same direction. Next I2, where is I2? Here. Capital I2 is equal to small I2. Okay, coming to I3, it is different. I3, now I3 its direction. I3 is its direction. So I3 direction is I1. Same direction is I1. So I1 minus I2. Because I3 what we assume, that is the reference direction. From that point of view, in the same direction I1 is there. Opposite direction I2 is there. So I1 minus I2. If you assume this I3 in reverse direction, then it will become I2 minus I1. So like this, we have to form the equation. Let's have an example. Find the for the circuit, find the branch currents I1, I2, I3 using mesh analysis. Check the circuit. See here, voltage source is one is here, another voltage source is here. Here only resistance, not like the previous one. Okay, we have how many resistances? 1, 2, 3, 4. And how many voltage sources? 2. So how many branches? 6 branches are there. You can make here another node also, no problem, because these are in series, no problem. Okay, total 6 branches. But how many currents we need? 1, 2 and 3 currents we need only. Branch currents are 3 only. Okay. Now next we have to form a loop. First loop and second loop. First loop, what is the equation we can write? Because current is leaving from the plus, this I1 is leaving from the plus, it is minus 15. current is entering in the 5, it is plus 5 times I1. 5 times I1. Now current is entering 10. 10 times I1 minus I2. Because these are two currents are there in this 10. Two currents. I1 is downwards and I2 is upwards. So I1 minus I2. Next, and current is entering, not leaving, entering. So plus 10. So be careful. Here it is minus 15. Here it is plus 10. So sure. So next, first equation. Now coming to the second loop. It is start from here, no problem. 6, you can start from 6, no problem. So current is entering. So 6 times I2 plus 6 times I4. Okay. 6 times, this is 6 times this I2 plus 6 times I4. Now current is leaving. Leaving means minus. Minus 10. Now, no. Our direction, plus 10, plus 10, plus 10, I2 is the reference. So I2 minus I1. I2 minus I1 plus 10 because current entering the resistance. I2 is the reference point. Okay, now check. Now minus 15, our what we checked, okay. Now plus 5 I1, then 10 times I1 minus I2 plus 10 because entering. So if you rearrange, you will get this equation 3 I1 minus 2 I2 minus equal to 1. Now coming to the second loop, somewhat tricky. You can check here. 6 I2 plus 4 I2, good. 10 I2 minus I1, okay. 10 I2 minus I1 minus 10 because leaving. Yes. Minus 10 because leaving. Now rearrange this equation. I1 is equal to 2 I2 minus I1. You can put I2 here also. I1 minus 2 I2 equal to minus I1. You have to rearrange this one. Okay, now by using elimination technique, I1 is equal to 2 I2 minus I1, substitute here in this. Then you will get I2. That is 1 ampere. Then you will get I1. That is I1 also 1 ampere. I2 is also 1 ampere. I1 also 1 ampere. Now what is I1? Capital I1. Branch current I1 is nothing but small I1. That is same 1 ampere. What is I2? Loop current I2 is nothing but capital I2. That is also 1 ampere. Now what is I3? I3 how much? This I3. Capital I3 how much? This is the reference point. No. Current based upon the loop currents. What is I3? I1 minus I2. What is I1? Small I1? 1 ampere. Small I1. And small I2? 1 ampere. 1 minus 1, 0. So I3 is 0. Means in this branch there is no current. Okay? Okay. We can see with the Kramer's rule also. Matrix form. Now substitute 3 minus 2 here. 3 minus 2 here. Next 1 minus 2 here. Okay. Minus 1 is taking this side and I1 is taking this side. So minus 1 and plus 2. Okay. Anything is okay because he is moving this minus 1 to this side and I1 to this side. So minus I1 plus 2 I2. This equation how it will be? Minus take.
Because I1 is there and 2.
No. My sign is different. Sign check here. Here minus 1 is the this one. How much here? Plus 1.
Oh, for the result.
Yeah. That's why he rearranged. He rearranged this one with minus 1. He is taking that side and I1 taking this side. So when I1 is taking this side, what happens? Minus I1 plus 2 I2. So minus 1 and 2. Then other side 1. So this is the matrix form. Now just take the determinant. Delta, that is 3 into 2, 6 minus 2 into 1, 2 plus 2. So this is minus 6 minus 2, 4. So overall determinant is 4. Now determinant 1. You have to rearrange this 1 1 instead of 3 minus 1. 3 minus 1 you have to replace with 1 1 and find the determinant. So 2 into 1 minus 2 into 1 minus or minus plus 2 plus 2 4. Now determinant 2. 3 into put 3 minus 1 as it is, rearrange minus 2 and 2 with 1 and 1. This 1 and 1. So this is the determinant matrix. Now find the determinant. 3 into 1 3 minus 1 into 1. Then minus or minus plus. So 3 plus 1 4. So all are 4 4 4 only. So current will be 1 only. So I1 determined 1 by 1, that is 4 by 4, 1 ampere. Current I2 determined 2 by determined, so 4 by 4, 1 ampere. So same result is coming with elimination technique and with the matrix Cramer's rule method. So now you can substitute what is I1, I2, I3, same like this. So these are the I1 is capital I1 is 1, branch in 1. Capital I2 is 1 ampere in branch 2. Capital I3 is I1 minus I2 in branch 3, that is 0. So this is the first example. Now another last example for this chapter 3. Then you have to practice at your home. Some 4 questions I gave, I think. Okay, the question is find the current I0. Where is I0? Can anyone?
In the middle.
Yeah, here. At the 10 ohms resistance, what is the I0 is there. So he only mentioned what is the I0. No need to name it again. No need to name the current there again. Okay. Now we can name other branches. So the voltage source, the current is I1. This resistance 24 ohms. Current I2 I am assuming. And this one current I3. Okay. Something is 3 loops are there, but one problem is here. What is that? This yeah.
2 resistors.
No, this is this is correct only. This is a loop current, so small I1. This is a loop current, small I2, and this is a loop current, small I3. No problem. You can go ahead. So now coming to the loop equations. What are the first loop equation?
Minus 24.
Because leaving from the plus minus 24, entering here plus 10 I1. Later we'll substitute what is I0 later. Now first our loop equation we have to write. So minus 24 plus 10
I1 minus I2.
10 I1 minus I2. 2 currents are there. Here one loop, here one loop. 2 currents are there in this. Correct?
I1
Minus I2 because I2 is in opposite direction. Right? Sometimes if you take other direction, it is I1 plus I2. It depends. But now it is in opposite direction. So now coming to the plus 12 times I1 minus I3. Right? This is the important here. Now first loop. Now rearrange it. Next, you have to go to the second loop. Second loop is I2. Okay. Second loop, we can start from this 24. No problem. So 24 I2. Now here 4
I2 minus I3.
I2 is a reference. So I2 minus I3. Okay. 4 times I2 minus I3. I2 is a reference. Now coming to the plus 10 times
I1 minus I2.
I2 minus I1. Our reference where I am standing, that is the reference point. Okay. I am talking about I2. That is our main motto. Okay. I2 is first, then Baki. So I2 minus I1. So next third loop. Start with resistance, no problem. 12 times, which is the reference I3. So I3 minus I1 plus 4 times I3 minus I2. Now it is reverse, check. I3 minus I2. Now here, what is this? Entering the plus. So plus, entering plus 4 I0. We need 4 I0, right? So what is I0? Later we can substitute. Okay, Ohm's law. As per the Ohm's law, or directly, what is I0? I0 is nothing but I2 minus I1. I0 is downwards, right? So downwards, which is the same. I1 minus I2. I0 is, what is I0? Here.
I1 minus I2.
This I1 minus I2. I0. As per the loop current, right? Getting or not? You didn't get, right? Okay.
Could be
This I0 equation we want because I0 is a more unknown value, right?
Okay.
So we have to rearrange with the loop equations only, loop values only. So this is I0, downward. Downward, which is downward? I1. I1 is a downward, right?
Okay.
So that is reference, I1.
Okay,
And I2 is upward. So I1 minus I2.
And also could be I3 because it's
No. Only in this branch. Only in this branch we have to think.
branch, okay.
Yeah, we are rearranging I0. Where is I0? Here, only in this branch. Don't think about the I3 here. I3 is not dependent there. This I0. No. If whole length, okay, you are correct. But when the 4 ohm resistance not there, if 4 ohm resistance is not there, then it is a whole. Okay. So now check here once again what we discussed. Same it will come minus 24 plus 10 I1 minus I2 plus 12 I1 minus I3. You can rearrange in I1, I2, I3 format. Next second loop, 24 I2 plus or minus. Yeah. Plus 24 I2. Where is it? Yeah, plus only. Yeah, that one, 24. So don't confuse with 24 volts source and 24 resistance. Okay, plus 24 I2 plus 4 I2 minus I3, correct? Next, plus 10 I2 minus I1. Now rearrange this, it will become minus 5I1 plus 19 I2 minus 2 I3 equal to 0. Now for mesh 3, what is it? Mesh 3, 4 I0 we are starting. I am starting with 4 I0. So it is entering the current. So plus 4 I0 plus 12 I3 minus I1 plus 4 I3 minus I2 equal to 0. Now rearrange, now substitute what is I0. Okay, but I0 is nothing but I1 minus I2. See here, I0 is nothing but I1 minus I2. So substitute in I0 form, 4 I1 minus I2 you can substitute. Now open this equation, rearrange, minus I1 minus I2 plus 2 I3 equal to 0. So those three are the equations. Now make it in the matrix format. Let's take. What is this? 11 minus 5 minus 6. 11 minus 5 minus 6. Okay. Then minus 5, 19 minus 2. Minus 5, 19 minus 2. Minus 1 minus 1, 2. Minus 1 minus 1, 2. Yeah, I1.
Minus 1 and minus 2.
No, this is I2.
I2, okay.
Minus 1, then 2 I3. So minus 1, 2. Don't confuse with the jumbo. Okay, next I1, I2, I3. On the right side, 12, 0 and 0. Easy now. More zeros is there, easy for our calculation. So that's you are happy. Now, how to find the determinant? I told you, take the 11 and this is your matrix. 19 minus 2 minus 1, 2 is the matrix. So 11 times, this is the matrix. Next, minus 5, then matrix is minus 5 minus 1 minus 2, 2. Minus 5 of minus. Minus 5 minus 1 minus 2 and 2. This is the matrix. Now take the minus 6, then this is the matrix. Minus 5, 19 minus 1 minus 1. Minus 5, 19 minus 1 minus 1 minus 6, that is. But here the summation. First one is plus, next is minus, then plus. So rearrange this one. Determinant. So 11 times. 19 into 2. Come, 38. 19, 2. 9, 9, 18, 1. Yeah, 38. Minus 2, 36. Okay. So 11 times 36 here. Now here 5 into 2. How much? 10. Minus 10. Minus 2. Minus 10. Minus 2. Minus 10. Yeah. Minus 10. Minus 2. Yeah. Minus 12. Correct. So this here minus of minus, it become plus. Now here 5 minus of minus plus. 5 minus of minus plus. 5 plus 19. How much? Plus. 5 plus 19, 24. Okay, so 24 times minus 6. Then you will get this much. 192 is the total determinant of this 3 by 3 matrix. Now determinant 1. How to determine 1? Just remove this column. 11 minus 5 minus 1. Remove this column and keep this 12, 0, 0. This is this one. Now find the determinant. 12, 19 minus 2 minus 1 and 2. First matrix. So next. Minus 5, 0, 0, minus 2, 2 is the second matrix. And for minus 6, 0, 19, 0, minus 1 is the third matrix. Now find the determinant 1, you will get 432. Now second one, 11, keep 11 minus 5 minus 1 as it is. This you have to remove. Minus 5, 19, minus 1 remove and keep 12, 0, 0. So keep 12, 0, 0. Now find the determinant 11 times first matrix, 0, 0, minus 2, minus 2. Next second matrix, that is 12 times minus 5 minus 1 minus 2 2. Third matrix minus 6 5 0 minus 5 0 minus 1 0. Now find the determinant, you will get 144. Third matrix. Third matrix is 11 minus 5 minus 1 minus 5 19 minus 1 12 0 0 is coming here. Now find the determinant 11 and this matrix is 19 0 0 0 minus 1 0. Now minus 5 matrix is minus 5 minus 1 0 0. Now 12 the matrix is minus 5 19 minus 1 minus 1. This is the matrix. Now what is the determinant? find the determinant of this matrix, and this matrix, and substitute here. You will get 288. So we got delta 1, delta 2, and delta 3. Now, what is the I1? I1, current I1, loop current I1 is nothing but determinant 1 divided by total determinant. So you can find I1. I1 is nothing but determinant 1 by total determinant. So 432 by 192, 2.25 amperes. I2, determinant 2 by total determinant, 144 we got by 192, 0.75. I3, determinant 3 by determinant. So we got 288. So 288 by 192, 1.5 amperes. So these are the I1, I2, I3. But now we didn't finish it. So the question what it is I0. Question is what is I0, right? So what is I0 equation? I0 is nothing but I1 minus I2. So what is I1? 2.25 minus 0.75. How much? 1.5. So I0 is I1 minus I2. That is 2.25 minus 0.75, 1.5. This is your final answer. Okay. He didn't ask the branch currents. What is I1, I2, I3? No. What question? You can answer that one. No need to go further. You stop here. So this is your this one. Now Supermesh, I told you I will delete this topic. So no need to study this one in the mid or final exam. Now summary will once again we'll check. Node analysis is the application of Kirchhoff's current law KCL at the non-reference node, because we have two nodes there. One is reference node, which is also called ground node or zero node. Other than that, we call it non-reference node. We will write a Kirchhoff's current law to that non-reference node only. We need n-1 equations, not more than that. So we express the result in terms of node voltages. By using Ohm's law, we have to write the equation in terms of node voltages. Solving the simultaneous equation gives the node voltages. Second, a supernode consists of okay, this you can no need to study, the supernode not there. Okay, now mesh analysis is application of Kirchhoff's voltage law, like here current law, here voltage law around meshes. We express the result in terms of mesh currents. Here node voltages, here mesh currents. Solving the simultaneous equation gives the mesh currents. So here again this is super mesh, no need to study. Okay. Nodal analysis is normally used when circuit has fewer nodes equation. So there is a best practice. Sometimes I may give the circuit and you will not tell. I will tell use any method, mesh analysis or node analysis, get the result. So at that time what we have to do is node analysis is normally used when circuit has fewer nodes, means less number of nodes are there, then you can use the node analysis. Now when mesh analysis normally used when the circuit has fewer mesh equations, which is less, you can use that one. If you have two mesh equations and mesh loops and 4 nodes, which one is better? Mesh. If you have more nodes, less nodes and more loops, then which one is better? Nodes. But here I will in the exam directly I will give use mesh analysis, use node analysis. I will clearly tell. Yeah, I will tell. I will in the question itself. I will tell. Use this analysis only. So don't worry about this one. This is for general knowledge. Okay, these are the 4 problems. I tell you 2 mesh analysis and 2 node analysis. You can solve at your home. Answers are there. Just verify it. If you are not getting, just WhatsApp me or tell me in the class. I will solve for you. Okay. So one is which one is this is the first figure. Check the figure number 3.52. This is the one for the first question. Next 3.51. This is the second. Next 3.54. This is the third one, not this one. And 3.60. This is the fourth one. So take the same circuit. So this is our.
So till now what we studied is mesh analysis, node analysis we already studied. In this mesh and node analysis we studied about 2 things. What are the 2 things we studied? Uh, in node and mesh analysis, we studied how to solve the equations. One is simultaneous equations, means removing the elements. Like if I have I1, I2 in 2 equations, how to remove the I1, then find the I2. Then remove I2 and find the I1. This is called removing the elements and find the simultaneous equation. First one we studied. The second one we also studied about the matrix method we studied. The means just to form the equations in the form of the matrices then we can solve the equations directly with the matrix multiplication, matrix division like this. We can do it easily. So these two methods we already studied, and the video also there I will share today, inshallah, by adding this remaining topic in this chapter. So we can see there. Okay, now we have to study two more topics in this chapter. That is, if we have a super mesh or if we have a super node. I think first one is super node. Yeah, so just I will go step by step. So we studied nodal analysis and mesh analysis. We already studied. Now we have to go with the nodal analysis with voltage source. So generally nodal analysis means what it is. So the circuit generally it has a current sources and different nodes we have, and in that one node will act as a reference node. Then we'll find different node voltages in the nodal analysis. Generally, we have a current sources for those circuits. Now let us take those circuits have some voltage source also mixed. Then we call it as a super node. So we'll study that one today. And if mesh analysis, generally we have a voltage source in the circuits. Then we solve the loop equations KVL by applying Kirchhoff's voltage law, and we find the currents I1, I2, I3. Okay, generally it has voltage source. Now let us take the same circuit is having the current source and voltage source both. Then we can how to solve by using a super mesh. So these two topics today will cover mesh analysis with current source, that is super mesh. So already we studied these many topics. Node analysis, how to solve. Generally, we assign a reference node and we'll solve the node analysis. Nodal equations we'll write V1, V2, V3, whatever. Then we find a simultaneous equation. Then we find two methods I told you. So that is called elimination method and Cramer's rule or matrix inversion method. These two methods we studied. Generally, elimination method already there in the calculator. Okay, and matrix also there. First you have to form the matrix, then apply in the calculator the Hasiba, then you will get the direct result. So that's also there. But you have to know how to form the equations by using KVL or KCL, Kirchhoff's voltage law, Kirchhoff's current law, use it, and how to make the equation, simultaneous equation. Then the solution will be easy by using the calculator. This is another example we have. Now we go to the super node. So this is Cramer's method. This is called matrix inversion or Cramer's rule method. Yeah. Nodal analysis with voltage source. That is, we call it as if it has other than the current source, if it has the voltage source in the circuit, then we solve with a technique nodal analysis, then it is called a super node. So we now consider how voltage sources affect the nodal analysis. So now we'll check. By using the figure 3.7, consider the following two possibilities. Where is the 3.7? This one. So generally, this is a circuit and we there is a two voltage sources here. There is no current source. Generally, the nodal analysis always have the current sources. Here there is no current source. It may have the current source also. Okay, but here we have voltage sources. Nodal analysis meant for only current sources generally. Now we have voltage source and we want to solve with a nodal technique, nodal analysis technique. Then what we have to do? We have two cases. One of the first case is from this node, we have three nodes, V1, V2, with three nodes are there and one reference. Total four nodes are there. And one is we taken as a reference, and first one is V1 voltage we have to find, second V2, and third one V3. Now here, case one, the voltage source is directly connected from node to the reference node. First case. Second case, the voltage source is connected in between the voltage source. These two cases we have to consider. Only these two cases will be there. Now, first case is very easy. Directly V1, if it is there in between the node and the reference node, then the V1 will be directly 10 volts. If it is positive on the upper side and negative in the lower side. If it is reverse, then minus 10. Okay, V1 will be directly 10. Here we cannot say what is V2 is 5 volts or V3 is 5 volts. We don't know. So we have some technique. So now case one, if a voltage source is connected between the reference node and a non-reference node like this one, first node and the reference node, then we simply set the voltage at reference node equal to the voltage of the voltage source. So we set the non-reference node V1 as a voltage of the supply voltage, the battery, you can say. So for example, in 3.7, the V1 will be directly 10. No need to write some voltage divided by the resistance. No need to write to find the current. Directly V1 will be 10 volts. Now case 2. This is very simple. If you come across like this, directly we can say V1 some voltage is equal to that voltage source. Now, case 2, if the voltage source is connected between two non-reference nodes, see, this voltage 5 volts, volts source is connected between two non-reference V2 and V3. Then the two non-reference nodes from generalized node or supernode. No, this is called the supernode. This, when it's connected between two non-reference node, then it is called a supernode. If it's connected between reference node and a non-reference node, it's not a supernode. Directly we can assign V1 is equal to that source voltage. Okay. Now, for those supernode, what we need? Generally, node analysis means which law we use. We have two laws: Kirchhoff's voltage law, Kirchhoff's current law. Node analysis generally we use with Kirchhoff's current law because node means at a node the sum of the entering currents equal to the sum of the leaving currents. So that is a node analysis. Which law? Kirchhoff's current law. And opposite for the mesh analysis where Kirchhoff's voltage law we use. But now when we have a supernode, then not only the Kirchhoff's current law, we have to apply Kirchhoff's voltage law also for that node. Both we need. Not one law we cannot use. Both laws we need. Means some loop analysis also we need. Kirchhoff's voltage law means some loop analysis. So we'll see that one, how to do. So what is a supernode? A supernode is formed by enclosing, means combining. Enclosing a dependent or independent. Which source these two are? Independent source. Sometimes dependent source also you can use. Voltage source connected between two non-reference nodes. Between two non-reference nodes. These two are non-reference nodes. And any elements connected in parallel with it. Some elements may be connected in parallel with it. With this, the resistance is connected in parallel. With this, the resistance, these two are connected in parallel. Okay? Sometimes it will happen. So this is a supernode. Now take an example. That example only, how to solve this case 2. So what we are doing? At the supernode in this figure, we find currents. So now assign the current numbers. Now in this resistance, let us take I1. In this resistance, let us take current I2. You can arbitrarily decide how the current is flowing. Direction is on you. Now in this resistance, current is going downwards. Let's take it is I3. And in this resistance, the current is flowing in this direction, I4. Directions are up to you, no problem. Later, the result will come positive, negative, we can decide. Now, you just assign the current numbers and the direction. That is I1 in the 2 ohms, I2 in the 8 ohms, 6 ohms, I3, and 4 ohms, I4. Now, decide the KCL at these two nodes because this is supernode. Supernode means we have to just omit the voltage source at that point. And together, we have to take the equation of that node. Not one node. Now, two nodes become now one node. V2 and V3 together will become one node now. When it has a voltage source between two nodes, that is non-reference nodes, two non-reference nodes, there is a voltage source. Then just think there is nothing and join these two nodes and write the KCL, Kirchhoff's current law. What is Kirchhoff's current law? Currents entering that node sum is equal to currents leaving that node sum, right? So what is the currents entering in V2? I1. Current leaving in V2? I2. I1 is equal to I2 generally. But we have to join these two nodes. So here also, what are the current entering this complete node? I1 is entering, I4 is entering. So I1 plus I4. What are the currents going out? I2 and I3. So I2 plus I3. So I1 plus I4, I2 plus I3. So don't confuse here. The supernode property is like that. Just we have to see that, remove that voltage source and join these two nodes and write the KCL, Kirchhoff's current law. Complete all the currents entering and complete currents leaving. So next, what is I1? What is I1? Based upon the nodes V1 and V2, it is V1 minus V2 divided by 2. I1 is nothing but V1 minus V2 divided by 2. This I1. What is I4? Here, where this is I4. V1 minus V3, these two voltages. V1 minus connected between V1 and V3. So V1 minus V3 Taksim Arba. That is by 4. There is a current. Now I2. What is I2? Between V2 and reference. Reference node is 0. So V2 minus 0. V2 minus 0 divided by 8. So it will give the current. Now I3. I3 is this one. Same. V3 minus 0 divided by 6. So this is the another current. So this is you got equation. Now rearrange this equation. Now to apply Kirchhoff's voltage law, now you can rearrange, you can write the equation in terms of V1, V2, V3, V4, it will come. No problem. Now already we know what is V1. What is V1? 10 volts. So apply here, V1 is equal to 10 volts. Now the equation become only three unknowns, V2, V3, V4. Okay. Now we go for the another equation, Kirchhoff's voltage law on this. So to apply Kirchhoff's voltage law to the super node, we redraw the circuit. We have to just redraw the circuit, Jadid circuit. We have to draw the new circuit with some modifications. What are that? And going around the loop. Okay, so this is your circuit. So just forget about the remaining elements, and the elements connected here means only keep the voltage source and remove the resistances of that one and remove everything. Okay, see here, resistance removed, resistance removed, resistance removed, resistance removed. Here voltage source also removed. Only we need this loop. Only we need this loop. Remove the resistances and write a loop equation. Loop equation. Okay, write a loop equation. And from V2 to 0, what is the voltage? V2. From V3 to 0, what is the voltage? V3. Okay, from V3 to the 0 reference node, it is V3. V2 to 0, it is V2. So now write the loop equation. How can we write the loop equation? Current leaving the plus terminal. What should be? Here, current leaving the plus terminal. V2 will be plus V2 or minus V2? Any current leaving from the plus terminal is minus V2. Then current entering the plus terminal, it is plus. So what is that? Plus 5 volts. That is V2 minus V2 plus 5 volts. Then current entering also here also. So plus V3 equal to 0. What is the KVL? Kirchhoff's voltage law. What is it? Sum of all the voltages in that loop is 0. Algebraic sum, maybe minus or plus. So how is the minus plus is coming? If the current direction, the current is leaving from the plus terminal, it should taken as minus. If current entering the plus terminal, it is taken as plus. So here current leaving from the V2, it is minus V3, minus V2, current entering, and what is the voltage? 5 directly, because here V2, V3 we don't know, but this one already we know 5 volts. And current here also entering, it is plus V3. So this is your equation. Minus V2 plus 5, that is source voltage, plus V3 equal to 0. Now we got V2 minus V3 is equal to 5. So V2 equal to, you can write 5 minus V3 also. Now we got V2 also. Now from this equation 10, the previous equation what we have, that is V1 equal to 10, first equation. Next, second equation is here, where if you substitute the V1, you got the V2, V3, we got it. Now 3.12 in this equation, V2 minus V3 is equal to 5. So we got how many equations now? 3 equations. How many unknowns? Mafi malum kam. V1, V2, V3. So can we solve the equation? If 3 equations mawjood and 3 unknowns mawjood, we can solve the equation easily, right? So we can go it. Otherwise, without this equation here, up to here, okay, previous method, previous nodal analysis method, Mafi supernode. Gadim this, before this. What is happening before this? We got only 2 equations, 3 unknowns. So we cannot solve. So that's why we got a technique called supernode technique. In the supernode technique, what we are doing? We are God. Okay, in this supernode technique, we write the Kirchhoff's voltage law equation by removing the all other elements and writing the loop equation for that supernode. Then we got 3 equations, 3 unknowns. Then we can solve it. So what are the points to be noted here is, first one, the voltage source inside the supernode provides constant equation, means different equation from the voltage source, from the voltage sources. Okay, necessary to solve the node voltages. Okay, so with this super node, we write a separate equation which is not on the node analysis base, we on the KVL base, not on the node base, KVL base. So we can solve the equations. Second point, a supernode has no voltage of its own. Though this supernode means when you mix together V2 and V3, it is a supernode. It doesn't have any own voltage. V2, V3 will be separate only. It doesn't have its own voltage. Now, another point, last point. A supernode requires the application of both KCL and KVL. Kirchhoff's current law and Kirchhoff's voltage law is lazim. Must it is. Only KCL will not work. Okay, KVL will need for the supernode, and KCL also we need. KCL means join these two nodes and write the KCL, Kirchhoff's current law. All the currents entering sum equal to all the currents leaving sum. Next, redraw the circuit and write the loop equation by using Kirchhoff's voltage law. So with this, you get the final result of all the element currents and the voltages at the nodes. Everything you will get. So this is the supernode. Now one example we have. Let's check. For the circuit, this is a circuit. Now what you observe in the circuit? Generally, node analysis means we must have a current source already there, and we have a voltage source. Now it is not a general node analysis because it has a voltage source now. When it has a voltage source in the circuit, then we technique goes for the supernode. So now I told you two cases will be there in supernode. What is the first case? When the voltage source is connected between a reference node and non-reference node. This is the reference node, and non-reference nodes are V1 and V2. Is this voltage source is connected between reference and non-reference? No. So case 1 is obsolete. There is no case 1. Case 2. What is case 2? When the voltage source is connected between two non-reference nodes. So it is there. So only case 2 is coming. So case 2, what is the solution? We have to apply KCL, Kirchhoff's current law, and Kirchhoff's voltage law, both for this source, right? This supernode. So let's see. So now, so just remove this one and make these two nodes together. That is V1 and V2 will be together. Now assign the currents. Current already there here 2 amperes. No need to write the current number. Now we have to write the current number for 2 ohms and 4 ohms resistance. So what is the current here? I1. Let's take downwards because current go to the reference node. Here 4 ohms current go downwards. That is I2. So we need I1, I2, and another current is 7 amps and 2 amps already there. So what is the equation for these two together? For these two I1, V1 and V2 together node, what is the KCL, Kirchhoff's current law? Equation will be together it is. So currents entering at these 1 and 2 nodes is 2 amperes only, right? Only 2 ampere is entering. Remaining 3 are leaving. So 2 ampere is equal to leaving currents are I1 plus I2 plus 7. So this is the equation for the node. 2 equal to I1 plus I2 plus 7. 4 items are there. So this is your first equation. How many nodes we have? 2 nodes. How many equations we need? Minimum 2 equations, right? So we got first equation. We need another 1 equation. So how can we do? Just now express what is I1 and I2 first. What is I1? I1 is nothing but I1. That is, this is the current. I1 means V1 minus reference node 0. V1 minus 0 divided by 2. V1 minus 0 divided by 2. Now what is I2? This is I2. I2 is nothing but V2 minus reference node 0. V2 minus 0 divided by 4. V2 minus 0 divided by 4. Now V1, V2 rearrange, multiply both sides with arba 4 times. This will be 8. And here 4 times means 2. 2 into 2 will cancel. 2V1. That is 2V1. Here also 4 will cancel. Just V2 will come. Now here 4 zarb saba means 4 into 7, 28. So this is the equation. Now we can rearrange this equation in terms of V2 is equal to minus 20. This V2 is equal to 28 minus 8. That is minus 20, and 2V1 going that side minus 2V1. This is the first equation we can say. Now next, because we need another format that is called supernode KCL we did. Now we need KVL also, Kirchhoff's voltage law. That is, remove all the elements, just keep that loop only with the voltage source. So with this loop, V1 will be here because the V1 with the reference V1 only. And V2 will be here, V2 with the reference node V2 and so voltage source. Now write the loop equation, Kirchhoff voltage law. Current leaving from the positive terminal, that is minus V1. Current also leaving from the positive terminal, that is minus V2. Minus V1 minus V2. Current entering the positive terminal plus V2. So we have minus V1 minus 2 minus plus V2. So this equation we can write, see, minus V1 minus 2 plus V2 equal to 0. Rearrange this, V2 is equal to V1 plus 2. Now we got one equation here, we got another equation here. So two unknowns, two equations. Can we solve the problem? Yes. So V1 will be with these two equations, 3.31 and 3.32, we can solve the equation. V2 is equal to V1 plus 2 is equal to minus 20 minus 2V1. Now substitute, we will get the V1 as minus 7.33 volts and V2 substitute there, then we will get minus 5.33 volts. So note that the 10 ohm resistance does not make any difference because it is connected across supernode. So we no need to assign any current to this 10 ohms resistance, no need, because it is connected across the voltage source of the supernode and these two nodes becoming one node. So there is no effect if the resistance is there or not there, no effect. So this is how we solve the supernode. Any doubts? So next we'll go for the super mesh. So mesh analysis already we studied by using the Kirchhoff's voltage law, that is loop equations. We have to write the loop equations. So we'll go to the directly the super mesh. Here also same two techniques we use, simultaneous elimination techniques, simultaneous equation elimination technique, or Cramer's rule, or we call it as a what we call matrix method. So these all we studied in the previous class. Now we'll go to the super mesh. That will complete our chapter 3. Yeah, mesh analysis with the current source. Now let us take what is a mesh analysis. Generally, we go with it when the circuit having only voltage sources. We use mesh analysis. Now let us take the circuit having more voltage sources and one or two current sources. Then the problem will come. So for that, we go for the super mesh. Now let us take here, for example, in this one, what you are observing, there is a one voltage source, there is a one current source, right? Now we have two possibilities again here, like the same there. What are the possibilities in the super node? We have two possibilities. One is the voltage source connected between a reference node and a non-reference node. So that is a simple case. Just the non-reference node equal voltage is equal to the voltage source. That's it. Second one is the problem where we apply KVL and KCL. Same here also. When it is connected in the loop, the current source is there and these two are the resistance, and then the current source, the I2 will be directly the current 5 amperes. Like the voltage V2 will be the directly the voltage source. Here the current will be the loop current I2 will be the same as the source current. So see, first one, when a current source exists only in one mesh, we have to check this current is in only one mesh. This is not disturbing the other mesh. So the current source is not in the between two meshes. It is only in one mesh. Then what is the equation? We set I2, here I1, I2 we consider. So we set this I2 is equal to 5 only, because whatever the current is from that source only, it's not dependent on other currents. So I2 will be minus 5 amperes. Why? Why minus? Because we assume the clockwise direction of I. So that's why the current is opposite. So minus 5. So write a mesh equation for the other mesh on usual way. So other mesh, you can write the normal mesh equation, voltage summation equal to 0. So this is case 1. Now case 2, let us take another circuit. Okay, write the another mesh equation in this one. What is the another mesh equation for this? Current leaving from the positive minus 10, current entering 4 into I1, current entering 6 into I1 minus I2 because these two are opposite. So 6 into I1 minus I2, 4I1 minus 10. Now we already know what is I2. Substitute what is I2 here, then only I1 is unknown now. Now find I1 is equal to minus 2 amperes. So like this we can find easily if the current source is in only a independent loop, not a dependent loop. In between loops, if it is not there, only independent is there. Directly we can assign that loop current as the source current and apply other loops with the normal Kirchhoff's voltage law equations, loop equations. Then we can substitute. Now, case 2. So, what is supermesh? Supermesh results when two meshes have the dependent or independent current source in common. So, first case is not a supermesh. Supermesh is when a two loops having a common current source. Two loops is having a common current source. Let's see the example. See, this is loop 1 and this is loop 2. Where is the current source? Here. So, when there is a two loops are having common current source, then it is a super mesh. Now, how to solve this one? Case 2 we call. When a current source exists between two meshes, consider the circuit what is shown. We create a super mesh by excluding the current source and any elements connected in series. We exclude the current source. Just that in this branch, what are the items are there? Maybe two resistances, maybe three resistances in that branch, complete branch, and current source. We just eliminate it. Just remove it. That's it. Then we'll remove it and we'll write a node equation at that. Already a loop equation is there, right? Node equation also we need, KVL, KCL. So, okay, like this. Just remove this one. Just remove these two items and redraw the circuit. Then loop equation will be same. I1 and I2 will be there. But just remove these two items. So this is called super mesh. How to solve? Like this. Now write the loop equation for the complete. For this complete. Previously, we had to write two different loop equations. Now here only we get one loop equation. Maybe the I1, I2 is different, but we write only one loop equation. Just check what is the loop equation. Current is leaving from this positive terminal. So minus 20. Current entering the positive terminal of the 6. What is 6I1? Now here, current entering the positive terminal of the 10. So current entering. So plus 10I2. Now current entering the 4 ohms. So plus 4I2. So this is the equation. Minus 20 plus 6I1 plus 10I2 plus 4I2 as per the loop. So we can rearrange this one. 6I1 and 14I2 equal to 20 will come if you rearrange and solve this equation. Now we need another equation because this is having I1 and I2. We need two equations to solve the problem, right? Only one equation we got. So for that, we need a node analysis. Check here. So this is one, what we have. Now we write a node here, some node with the reference node. Now we make this node, reference node, and we write the currents as per our directions. This is the current, I1 is flowing out. This current flowing into the node. Now write the node equation to this one. How many currents are there in this node? Anyone? Come current mojud in this node 0. How many currents are there? Come Majimo, currents. 3, 2. No. The joining in the node. How many currents are joining together? How can we know how many currents are moving and coming in? By lines connected to the node. How many lines connected to this node? Are elements connected to that node? This node. How many are connected? Wahid, Itnain, and Talata. 3 are there. So how many currents should be there? 3 currents, right? So for that node, we need a 3 currents equation. Okay. Positive, negative, we will decide. So in this node, 3 currents are there. What are they? I1, I2, and 6 amperes. 6 amperes are there. Now write the equation for this. What will be there? Currents entering the node. How many currents entering the node? Only I2. Currents leaving the node. Barra. How many currents? 6 amperes and I1. Right? So I can write I2 is equal to 6 plus I1. I can write. This is called node analysis. So I2 is equal to I1 plus 6. Now we got this second equation. We got the first equation. With these two equations, we can solve the problem. So So solving the equation, that the previous equation was 6I1 plus 14I2 equal 20, and the second equation is I2 equal to I1 plus I2. Now we can solve this one, we get the result. I1 is minus 3.2, I2 is 2.8 amperes. So like this, we can solve the super mesh. So what are the 3 points again here? What we have to understand. First one, the current source in the super mesh. The current source in the super mesh provides the constraint equation from the current source necessary to solve the mesh current. So the current source in the super mesh provides a necessary node currents at the reference node. Then we can have an extra equation. A super mesh has no current of its own. So this super mesh doesn't have any current number. See, I1 we have in this loop, 6 ohms we have I1 here, and this I2 we have. But in this branch, there is no separate current. There is no separate current. Its own source current only will be there. Okay, a super mesh requires the application of both KVL and KCL like the previous case. So like this, we have to consider summary. What we studied, we'll just see. The first one, node analysis is the application of Kirchhoff's current law. Node analysis is the application of Kirchhoff's current law at non-reference nodes. Because in node analysis, we make a one node as a reference, remaining as non-reference. So we omit that reference node and we'll write the equations for the non-reference node. We express the result in terms of node voltages. KCL we write, but we express the equations in terms of node voltages. Solving the simultaneous equation gives the node voltages. Second one, what is it? The supernode consists of two non-reference nodes connected by a dependent or independent voltage source. Two non-reference nodes. In between, there is a voltage source. Now, mesh analysis. Mesh analysis is the application of Kirchhoff's voltage law around mesh, means around loops. We express the results in terms of mesh currents. Here we have expressed the result in terms of mesh currents, I1, I2, I3. Okay. By default, we write the Kirchhoff's voltage law, sum of the voltages, but we express it in terms of currents. Solving the simultaneous equations give the mesh currents. Now, super mesh. A super mesh consists of two meshes that have a dependent or independent current source in common. So, now, node analysis is normally used when circuit has fewer node equations. Less nodes are there, 2, 3 nodes are there, we use node analysis, and more current sources are there, we use this one. Mesh analysis is normally used when circuit has fewer mesh, means loops are very less. Then we use the mesh analysis. Okay, now we have some practice problems here. Some 8 problems are there. This is on the general mesh and node analysis. And these 4 problems are based upon the super mesh and super node. So answers are also given. If you want, you can practice it. So this is how we finish chapter 3.